Hello, everybody. Welcome to this Highcon webinar on corrugated production with Highcon's Beam to See Nonstop. This webinar is being brought to you live here from Highcon's headquarters in Israel, and we will be demonstrating the system live to you. My name is Simon Lewis, and I will be hosting this webinar together with my colleague Arnon Grach. Before we start, some housekeeping. This webinar is being recorded so that we can reuse the content, and for those who are unable to join live, will be able to see this, to be able to view the webinar at a time of their choosing. Because of the number of participants, the lines are muted. We do have a question box at the bottom of the screen, and you're welcome to insert any questions you may have during the course of this webinar, and we will endeavor to answer the questions when we come to the end of the session. And now, let's really begin. Highcon, as you may well know, didn't start in the corrugated industry. In fact, our first product, the Euclid, was designed for folding cartons and was introduced in 2012. It was bought by customers in folding carton, but also by plenty of commercial printers who were squinting towards the folding carton market. 4 years later, we introduced the Beam with higher productivity for the same markets and the same applications. And therefore, it was no surprise that a number of core decisions were to stay the same. The sheet size remained B1 or 30 by 42 inches. And the configuration was based on a pallet feeder and stacker, since they are the mainstay of folding cartons and commercial printers. Then we were asked, can Highcon finish corrugated products? Well, the answer was yes, we can. We can cut the corrugated board, and our dark creasing technology can create the crease lines, the score lines on corrugated boards, even quite thick ones. And therefore, we modified the paper transport and the internals of our systems and introduced configurations of the Euclid and the Beam for the corrugated market. Then the questions really started, the feedback from the industry really started. First, they said the format is too small. And they're right, of course. Ideally, corrugated would have a larger format, but actually, that's not a simple thing to solve. And when we dig into the job basket of customers, we find very often that there's plenty of work that fits the current format, and therefore, it's actually not a showstopper. The second thing is they say the pallet-based configuration kills productivity. And they're right. If you think about it, the feeder or the pile in the feeder holds around 2,400 sheets of 350 micron board for folding carton. However, when you take that same pile height with a B-flute, which is one of the thicker boards that we can process, you only get 315 sheets in the pile. If you're thinking of a 2,000 sheet job, that's one pallet for folding carton and 6 pallet changes for corrugated. Of course, with a thinner flute, it would be fewer pallet changes. So Highcon started working with an experienced vendor to the corrugated market to change this system so that we would have a non-stop feeder, non-stop waste removal, and non-stop stacking. That's the Beam 2C non-stop that we'll be demonstrating to you shortly. Then the question is, how do we differentiate the different configurations in front of the customer? And there are 3 core factors. The first relates to run length. Typically, the pallet-based configuration is for running a few hundred sheets, perhaps up to around 1,000, whilst the non-stop is for longer runs of perhaps a few thousand sheets, up to maybe 22,500 square meters, 27,000 square foot, or maybe somewhere in the region of 7,500 pieces. So it's run length driven. The second is application based. Typically, display elements run shorter runs and are more suited to the pallet-based configuration, whilst packaging, shipper boxes, and so on tend to have slightly longer runs, and therefore to run more on the non-stop. And finally, there's the question of integration into the plant. With a non-stop, you can integrate directly with the plant conveyors, and therefore you can deliver piles directly onto the conveyor system, something you can't do obviously with a pallet-based configuration. Here in our R&D facility, we do not have conveyors, and therefore in our non-stop, we're working with pallets, so we can remove the pallet from the delivery with a forklift or with a pallet truck. So we have this portfolio with the Euclid 5C, the Beam 2C pallet-based, and the Beam 2C non-stop. And it's all about the right tool for the right job. Each of these products meets different requirements for different customers. And the right tool for the right job means optimizing for productivity, throughput, and profitability. Inherently, digital finishing is great for shorter runs, faster turnaround, toolless production, more sustainable production, but it's not just those. Using the Highcon system is a great way to add value and to create a slightly different job mix that has a higher value overall. Arnon is going to talk about all of this and more. So I'm going to hand over to Arnon, and I'll be back with you at the end of this webinar.
Thank you, Simon, and thank you all for joining us today. So in today's webinar, we're going to see the Beam 2C nonstop running production. I'm going to give you an overview of the system, the key components, and the technology. We're going to show you a full job setup from scratch, and I'll show you some examples of real products made from our customers, and I'll explain the benefits they gain from producing these products on their Highcon system. So we'll start with running the system, and let's first take a look at the job. Okay. Okay, so as you can see, even high-tech technology can run into the occasional jam. So we'll get the system up and running, and let's go on to some of the samples. I can talk about what our customers are doing while we're getting the system up and running again. So like I explained before, these are real products that our customers are producing. And I'd like to focus on some of the benefits that they can achieve. So first thing is enhanced value and novel designs that they can achieve. And this is a very lovely example. It's a package for rum bottles. And as you can see, this is a corrugated box with added value by laser cutting. And you cannot say that this does not stand out on the shelf. So it's not always necessary to have graphics or print enhancements. You can achieve a premium packaging at a lower cost and increase your margins. Here's another nice example. Okay, I just got a note that the machine is running, so let's take a look at what we're producing at this moment. So what we see here, this is the layout. It's a one-up, it's a B-flute shipper, and there are some functional elements which we'll talk about, and we'll show you this later. This specific job is running at almost 1,400 sheets per hour, and generally this system runs up to 4,000 sheets per hour, depending on the layout and the material. So I'll go to the proofing tray, and I'll take out a sample, and we'll take a closer look at one of the functional elements here. Okay, this is an opening mechanism. It's a tear zipper. Now, what we're going to do is make a change. We'll pause the system and we'll make a change in the job. So Idan, please pause the system and make the first change. So we're going to replace the opening mechanism but the package will still be the same. It'll be the same structural design, the same crease lines, and the same dimensions. Just the opening mechanism will be the same. So we're going to demonstrate to you how we can make this change practically on the fly. And this is impossible with the conventional equipment. And you can take this, this capability to create different versions for the same package. And if you imagine what it means when you're developing a new product design, and prototyping new die cutting tools, and if you look at the tear zippers, the perforation, you would typically need to order 2 or 3 additional perforation cutting knives and test each one of them on the die cutter to see which one has the best performance. So you would basically test the first one, take out the die, switch between the perforation sets, put the die back in, make adjustments on the machine, run a few seat checks, and so on and so forth. But with laser cutting, you don't need all this. You can easily optimize the design and laser parameters to get exactly what you need in a matter of minutes. So while done here is changing this job and resuming the production, I'll give you an overview of the system. So the Beam2C Nonstop is designed for operating in streamlined production environments for corrugated packaging. Okay, we have the nonstop feeding, nonstop waste removal, and nonstop stacking and delivery. With this continuous operation, we can around double the effective throughput when we compare this to the pallet-based configuration, because obviously we don't need to replace, unload and load these pallets. So this feeder is pre-feeder ready, and it can be integrated to the plant's feeding conveyor. And at the end, we can integrate to the plant's collection conveyor. And if you see this feeder, it's a bottom feeder, and it supports corrugate boards up to 4 millimeters. That includes microflutes, B, C flutes, and double wall up to 4 millimeters. After the feeding, the boards go to the registration table, where an initial alignment, mechanical alignment, is performed, and the boards are pushed to the front wall right here. Afterwards, they reach the registration area, where we have sensors detecting the sheet edge and cameras detecting a print mark if we want to correct a print-to-print variation. So typically in corrugated, we would run print side down, so we have a bottom camera for this. But if for any reason you would like to run these boards with the print side up, we can easily flip the layout in the UI, and the system will adjust the creasing and cutting coordinates accordingly. After the registration, the boards go into the dart creasing station. There are 2 drums here. The upper drum has the creasing rules, and the lower drum has a flexible blanket that acts as a counter to the creasing rules, to the top drum. So this is like a female counter. The creasing rules are made from a high-tech material, which give them the strength and durability to run at high speeds and consistent performance. Right here, we can see the user interface. It's a touch screen. Everything is programmed and performed on this touch screen. And after the dart creasing station, we get to the first exciting part of our system, the laser cutting. What you see here is the laser chamber with 3 lasers cutting the board simultaneously. Each laser is just above 1 kilowatt of power. And you can see they're simultaneously cutting the board while it's moving. The control of the lasers, the software, and the algorithms are all developed at Highcon. After the laser chamber, we'll show you the stripping station. Okay? The important part about this stripping station is that it requires no tooling, so no extra cost or setup for the stripping. As you can see, all the scrap, the cut particles that remain are brushed off with a brush. In the pallet-based configuration, we have waste bins situated underneath this board, but they fill up and the operator needs to take this out. So what we have here in this non-stop waste removal, we also have a shaking conveyor, and all of the scrap is collected by internal conveyors and disposed to the main waste conveyor of the facility. While the boards are elevated to the stacking, we have a proofing station where we can take out samples for quality assurance during the production. And in this area, we have the stacking elevator. So boards are pushed to the stacker and they're piled to the stacker. When the pile reaches its maximum height, the elevator goes down and is delivered to this conveyor. So we have two configurations for this as well. We can either deliver the pile directly on a conveyor belt, and then it will move on to the integrated collection conveyor of the plant. And we can also stack the pile on a pallet. So if the stack reaches its maximum height, the elevator will go down and a new pallet will be automatically elevated to support the rest of the production. And all of this is done, of course, in continuous operation. So let's take a look at these jobs that we've just produced. And I'll make a switch with the cameraman, my colleague Tal, who's the application specialist and designer at Highcon. And we'll take a look at what we've just produced.
Okay. Can you hear me now?
Yep.
Yeah. Thank you. So, as you mentioned before, we have two designs here, two opening mechanisms that you saw Idan changing on the fly. And so this package, it's essentially the same, just the opening mechanism changes. So this is a cool e-commerce package. And it's basically an Amazon design, but we got rid of the glue and the sticker, and we made it a sustainable monomaterial design. And also this is temper evident. So it uses nice Highcon features that I'll show you. Let me just fold this. Okay. Okay. Okay, so now I'll show you how it folds. You can see these two locks here. So these relate to the BCT that you talked about earlier. These do not crush, and therefore they're very strong. And what we do now is we close the package and we thread through these two locks here and the package as normal, as we normally would. And we overlap these locks here. And if you can zoom in, we latch these inside, essentially creating a seal package. And okay, so the only way that this package can be opened is by the recipient that actually receives it. So this is completely tamper proof. And if you do try to open it beforehand, it will rip open the locks here, and it will create an effect which will prove that this was in fact opened and the product was replaced, or the something was changed in the operation. Okay, so let's so this is how you would open this. This is how the recipient of the package would open this. Okay, revealing the internals. The product will be here. Okay, so this is one of the opening mechanisms. Again, I will show you the other mechanism. We have this prepared here. So this is the zipper we've talked about. And this would rip open and create these two designs, which are the same external layout with a different internals, with a different opening mechanism. Okay, so what we've done here is we changed the opening mechanism easily on the fly. This is, you can also play with the frequency of the perforation here. As you can see, if you can zoom in, we have these little cuts here. Obviously, this is a perforation, but here with the Highcon system, you can change this dynamically, and you can change the size of the cut versus non-cut. You can make it bigger or smaller according to the substrate that you've received. You're not restricted to any conventional rules in die making, and so this is a lot of fun to have a nice design. And yeah, that's it for now. Back to you, Arnon.
Great. So as Tal has been showing the products that we've just produced, Idan has started with creating the recipe, creating the new setup. Let's say it's about 25 minutes past the hour, and we'll check on the time. So what I'm holding here, this is a clear PET foil with creasing rules. This was just unmounted from the previous job. This is the creasing scheme of the previous job. During the setup, the PDF file of the layout is loaded. The system reads the creasing information and extrudes the creasing rules onto this clear PET foil when it's mounted on the upper drum. And here's another exciting part of our technology. This is Highcon's proprietary technology in its 5th generation. The crease rules are made out of photopolymer material, which is developed and manufactured at Highcon. And we control several things of the mechanical properties of the material. And the first thing is that we control the viscosity of the material that's being extruded in a paste formation. As you can see, this is the writing process right now. And we control the rule height and shape to fit exactly what we need for the application and material and stock in hand. We can also change the shape and the rule height. And not only that, we can decide on different rule heights for flute direction and for cross flute direction. So we can have different rule heights on the same creasing scheme in order to get the optimal performance that we need. All of this is done only by software, so there's nothing changed, no mechanical or anything changed. It's all done through the software. The operator selects what the what the rule height and shape he needs for this application. Okay, after the writing process, the polymer is hardened, it's cured by UV and is hardened. And basically, this creasing scheme, the foil is good up to 50,000 impressions and 5 reuses for repeat jobs. So the same foil that you just saw, we can store this away. And in a few days, weeks, or months, if we have this reoccurring job, we take the same foil, mount it on the top drum, and run run the job. So all of these parameters are optimized during the job setup, so we get the optimal performance for running our products in folder gluers. And another thing, we compared to conventional dies, we use much less material and much less supply and manufacturing chains, which makes a less negative impact on the environment. Okay, now let's take a look at the user interface. We have a user-friendly flow for setting up the job, and we start from left to right. So we basically have the job details, the job name, substrate, type of substrate, number of sheets required, and we punch in this data. Then we move on to the check cut. This is where we optimize the laser parameters, the laser speed, the power, different layers of laser cutting are programmed here, the cutting settings. In the next step, we have the dart writing. This is where we set the parameters for writing the crease rules. The next stage is checking the registration. So we can see that the creasing rules, the crease lines, the cutting lines, and the print are all registered correctly. And the last part is running the production. Okay, so we'll let Idan continue with the job setup, and I'll go back to our samples of products our customers are making. I left off when we talked about enhancing value of packages, and here's a nice example of a dog snack. Okay, it's a relatively simple package, but you can see that there are cutouts. Okay, making this more attractive product. And also you can see through these areas to see what's inside the package. So typically you might see a boring rectangle or some kind of plastic window, but all of this is replaced with these cutouts. And they're nice examples, they're simple examples like this Easter gift box. Okay, it's basically a simple box, but it has a nice cutout, and it's very simply adding a colored carton from the backside, you get this nice effect. This even goes for bulky boxes. Okay, this is a heavy piece of hardware. Okay, we have the way to take this, but it doesn't mean it needs to look bulky and brown and boring. Okay, we have this added cutting, and also the same idea as before. They just stuck a brand color carton from behind to get this kind of feature. One of the things about Highcon technology is that it's non-crush. Okay, so we recently had a peer review publication from a leading European university analyzing the box strength of boxes produced on Highcon compared to boxes produced conventionally. They tested things like BCT, ECT, shear, all of these things, and the conclusion was that boxes produced on the Highcon are stronger than boxes produced conventionally. And what this means is that you can actually make the same package on the Highcon and use less material and still achieve the same box strength. So by using less material, you can cut costs on material, and you can also contribute to lightweighting of shipped packages. Here's another example for sustainability. Okay, this is a cocktail gift package, and they made use, okay, for a mono-material packaging. Okay, this is sustainable packaging, replacing the plastic trays that we used to see or the foam inserts with an e-flute tray in order to support the bottles. Okay, let's see. Here's another nice design. Just a combination of a nice print and a brown board. Pretty special design. And you don't need too much hassle with the laser cutting. You can do something nice that looks really great. Let's see. We also have some packages where our customers can reduce their costs from extremely or exceptional high costs of die cutting. So one of these examples would be small packages. Okay, this could be a simple package, but the amount of packages, the amount of ups that go into the layout really increase the die costs and also the setup of the conventional tool. So our customers are delivering these products even if the runs might be longer than what they would typically do, because they can still remain profitable. And here's another example of a tray. This is a specific tray, fruit tray. This is for cherry tomatoes. We can also see these for fruits or for bread. And what we see more and more of these products coming out because of the surging demand of sustainable packaging. We used to see these in plastic in the past, and now it's done with recyclable paper. So you see the cutouts that they've done with the Highcon system. Now, could this be done conventionally? Yes. Would it be profitable? Probably not, because these run lengths are getting smaller, they're getting shorter. And of course, businesses are trying to cut their costs from inventory, and some of these are also seasonal. So what you get here is something that probably you won't do conventionally. And there's high value in these kinds of applications as well. Okay, so let's see how we done is moving along. Okay, the next job that we're creating here, it's actually the insert for the shipper that we just produced. It's an e-flute insert. We'll take a look. Idan right now, he's running the first sheets in order to look at the parameters, look at the tuning that it needs to do. So let's take a look at the at what is running. Is this already in production? Oh, okay, so we've already started the production. I'll take a look at my watch. It's 36 minutes past the hour. So basically, we've created this setup from scratch in, let's say, 11 minutes. Okay, so it's 11 minutes for a job setup, and it doesn't include the lead times for the die tools when we're doing this conventionally. So let's take a look at the layout here. Just a second. This job is running at 2,000 sheets per hour. And we can see this layout. Let's take a move. Let's take a low at the production. You can see the laser cutting. Okay, so Idan, you can stop the system, please. And we'll take a look at this next job, these inserts. I'll switch with the cameraman again.
Okay.
So Tal can show you
Okay.
what we've just produced.
So if we have the insert here, yes, we do. Take it straight out of the proof tray. So, so this is a suspension design insert, and what we're going to pack here, I'm going to show you. We have a nice painting here by Menashe Kadishman, an Israeli painter and sculptor, and we're going to put this inside the tray here. So this tray has these special intricate cutouts that will fit the product exactly right. Okay, put this here. So you would usually, well, you can close it for now. Thanks. So this would be packed diagonally and then taken like this. Then whoops. Okay. So this is inserted like this into the package, and this is a suspension insert. Okay, so what this does is actually hold the painting in the air, in space, and it prevents the possibility of impact to the product. Okay, so I will close it now. So as you can see, also this insert is a little warped. This is intentional in order to make this clamped into the insert. So let's close this. Again, as before. Okay, let's open it. And there you have it. A lovely painting, arrived unharmed to the final destination. That's it. Voila. Back to you.
That's great, Tal. So that's about what we've planned to demonstrate to you. I'll make a short summary of what you've seen today. So we've seen the Beam 2C nonstop running production. We made a change in one job, okay, for versioning of a package. We made a full setup, and we ran an additional job for the inserts for the shipper that we initially produced. I gave you an overview of the technology, the key components of our system, and we talked about some real products showing what they can achieve with enhanced value for packaging, novel designs, sustainability and box strength, and also how we can save costs on exceptionally expensive die tooling for specific jobs. So thank you for joining us, and I'll hand it back to Simon. Here, let's replace this one.
Okay. Arnon, stay here. Arnon, stay here, please. It's working now. I'm sorry, guys. I didn't turn on in time, so you can help me answer the questions.
Sure.
Okay. So before there's some questions that got in. How many impressions can the scoring map produce? As you said, I think, I'll see if I get it right.
Yeah.
You said we can do up to 50,000 creasing actions.
Correct.
And we can replace we can reuse the foil up to 5 times.
Correct.
Okay, which corrugated market segments do we serve? We serve display, we serve packaging, we serve e-commerce, web to pack, and we're pretty flexible. As this is going to deal with the next one in terms of the flute range. We can do anything up to 4 millimeter flute, right? So
Correct.
it said single wall and double wall.
Double wall up to 4 millimeters.
So that, in a sense, defines the applications based also on the format of 30 by 42 inches. We're not going to do packaging for refrigerators. They're
That's
too small.
correct.
No, I mean, we're too small, and typically they may use heavier board. Can the foil be reused? Yes, as we said, up to 5 uses. Can the crease rules have different heights? Maybe you'd like to repeat.
Yes, I'll repeat this because this is a special part of our technology. We can optimize, we can change the rule heights according to the application and the material that we have in stock. But it's not only that, we can also decide on different rule heights if it's in the flute direction or the cross flute direction. And all of this is done with the software just by selecting the different parameters on the UI.
And as you said, I think, Arnon, it's all done with the same physical nozzle. So we don't need to change some hardware element in order to make a different rule.
Exactly.
Very smart. Okay, next question. Is there a non-stop configuration without the pallet?
Yes. So we have, of course, we're not connected to a production line, and we're not connected to conveyors. So in this case, we are using the pallet-based configuration. And what we can do, we basically have the ability during the production, when the pile height reaches its maximum, the stack will go down, the pallet and the stack will move out of the system, and a new pallet automatically will replace the old pallet, be elevated up where the sheets continue to be stacked on it.
Great, thank you. And the last question I have, unless there are any more, I'm asking my backroom colleague to make sure there are no more questions. What is the speed of the Beam 2C? I'm going to take that one. The speed of the Beam 2C is variable. I think this is a really important point to make. You saw it running at around 1400. You saw it running at around 2000. It'll run up to 4,000 sheets per hour. The up to is a function of the amount, essentially, of laser power needed to perform the necessary cut. The creasing will run at that speed without a problem, but you need laser power. The thicker the board and the more you need to cut, the slower it'll run. So it's no surprise, for example, the shipper on a B flute ran slower than the insert on an E flute, because you need more power to cut it, and the laser power is finite, and we spread the laser power in the most effective way possible. So the answer is up to 4,000, but let's be clearer. What we see is that customer averages run around the 1,500
Correct.
sheets per hour mark, typically. Although you can do a really complex cut. Remember that, I don't think, I don't know, you actually showed the black bottle, the black box, did you? In this example, this really beautiful alcohol package, which has got all these very, very fine cuts and no print, something like this will have run very slowly because you're cutting and cutting and cutting each sheet. But you would never do a job like this conventionally. The cost of the die and the complexity would be fearful, right?
Correct.
Thank you. So last call for questions. I don't see anything else. Chaim in the back room, will you send me a sign that this is it? Nothing. He's typing. Let me just be sure that we've got it all. And Chaim is saying, can you do proofing? So if you mean, can we check what we're doing? The answer was clear. What you saw was that Arnon and Tal were able to pull sheets from here. The operator can sell the system to drop a sheet into the proof tray, then we can take it out. So if I reach in the back, 1 second, this was a waste from what Tal already took. But if I do this, we can see that that insert, this was the whole sheet that ran, and I've taken it out of the proof tray. So obviously we can define how often to put a sheet in here, or we can say just do it now on demand rather than pre-planned. And with that, I'm going to understand. 1 second, Chaim's typing again. Is there another question coming in? Okay. No, I think that that's it. So at this point, I'm going to say, on top of the summary that that Arnon gave you about what we saw, I'd like to draw you back to one really important point. It's what we call the right tool for the right job. We acknowledge that digital finishing is not a universal solution. It coexists with analog finishing, which can do longer runs and standard boxes that are done every day, every week, every month. It also coexists with CAD tables that will do 1, 2, or 3 items, or maybe 10 or 20, but not a couple of hundred. You'd certainly be better to do that on a Highcon. The right tool for the right job is about optimizing the mix. It's about having a choice of how to make your production on your floor, and then routing work based on the optimal throughput, the optimal productivity, the optimal profitability. Highcon has real value. It can do standard jobs. It can do the high value jobs. You saw how we switched the opening mechanism, how we have a digital flexibility that's just hard to imagine in the conventional world. We bring a lot of value, and we, our team around the world, will be delighted to engage with you if you see potential opportunities to explore how Highcon digital finishing, whether it's with the Euclid 5C, the Beam 2C pallet-based, or the Beam 2C non-stop, can fit into your corrugated operation. Thank you for joining us in this live broadcast today from our headquarters here in Israel. We hope this has been interesting to you, and we look forward to you joining us in a future webinar, and we will see you again. Thanks very much, and goodbye for now.